Hi dear students, in this video we are going to study about equal matrices and addition of matrices. We are going to start with the equal matrices, and here is the definition. Two matrices are equal matrices if they have same dimension. So this part is also important for us. The dimensions, if they are not same, we cannot say they are equal, or if the dimensions are not same, we cannot add them. And their corresponding entries are equal. Corresponding entries are equal means here the first row, first column, and first row, first column should be equal to each other. So if they are equal to each other, we write A is equal to B, mean that two matrices, they are equal to each other. Here, since the dimensions are not equal in this example, they are not equal matrices, not equal matrices. And here, in this exercise, if these two matrices are equal to each other, entries should be equal to each other. So A1, 1, it should be equal to first row, first column, first row, first column should be 2. So it's equal to 2. Then A1, 2, it should be equal to minus 1. It should be equal to minus 1. A2, 1, it should be equal to minus 3. And A2, 2, it should be equal to 0. Let's continue with different exercise. Here, if these two matrices, again, it is given same. As you see, these entries here, this one and this one, this one and this one, they are equal to each other. So this one and this one, this one and this one, they are equal to each other. So the rest of them also, it should be equal to each other, which means x plus y is equal to 2, which means if I solve x plus y is equal to 2 and x minus y is equal to 2x plus 3y. In this case, I can solve this question by using the substitution method. Firstly, here x minus y, if it's equal to 2x plus 3y, I can send the x and 2x to the other side, like x minus 2x is equal to 3y plus y. It will be, I collect the x and y's on the same side, so minus x, it will be equal to 3y, or x will be equal to minus 3y. This is the first one. And I'm going to continue with I'm going to substitute this one here in the other part. X, if it's equal to minus 3y plus y, it should be equal to 2. So minus 2y, I substitute here this one here. Then minus 2y, it should be equal to 2. Y is equal to 2 over minus 2, which is equal to minus 1. If y is equal to minus 1, x should be equal to, x is equal to minus 3y. So x is equal to minus 3y, 3 times minus 1, which means x is equal to 3, it has to be. So find x and y and z, it says, but there's no z in the question, so find an x, y. We are going to solve the question and it's enough for us. So I can write x and y as an ordered pair, like couples. Here it's going to be equal to 3n minus 1. I can write. Okay, this is another question, and the logic it is same. The entries places should be, this is first row, first column, this is first row, first column. So for x plus 5 should be equal to 21. In the other side, here, in the other side, minus 2x minus 2y plus 3, 2y plus 3 should be equal to y minus 12. And 7 is equal to 7, 9 is equal to 9, 15 is equal to 15, minus 1 is equal to minus 1. So this is the first part. Then I'm going to continue for x plus 5 is equal to 21 case. It means that 4x is equal to 21 minus 5, which is equal to 16. 4x is equal to 16, and x is equal to 16 over 4. That's equal to 4. It has to be. On the other side, here we have minus 2y. Minus 2y minus y is equal to minus 12 minus 3. It should be known terms and unknown terms on the other side. Like terms also we can call. Minus 3y is equal to minus 15 and y is equal to minus 15 over minus 3. It might be, and y is equal to, here y is equal to 5. It must be. And we found x and y values. They are not ordered paired. That's why I didn't write in an ordered pair form again. But we can solve like that. Okay, now I'm going to continue with matrix addition. In matrix addition, also the rule is same. Dimensions must be equal to each other. If this is 2 by 2 matrix, the other one here, let me change the color. This is 2 by 2 matrix. So the other addend should be 2 by 2 matrix. The first matrix 2 by 2, second matrix 2 by 2. The answer again is going to be 2 by 2 matrix. And you're adding the only corresponding entries: A with E only, B with F, C with G, and H with D only in this condition. So here, as you see, we are doing the addition like this. It's very simple. We are going to solve, we are going to try to understand on the exercise. As you see here, the first matrix is A plus B, it is asking. I'm writing immediately A plus B, 5, 0, 4, 2, 3, minus 1, plus 2, 2, 1, 5, 3, and 7, 3 and 7 it's going to be. And here, as you understand, firstly I'm going to add 5 with 2, then 0 with 2, then 4 with 1, and it's going to continue like this. Let's do the same thing here. 5 with 2, 5 plus 2 is equal to 7. 0 plus 2, it's equal to 2. 4 plus 1, it's equal to 5. 2 plus 5, it's equal to 7 again. 3 plus 3, it's equal to 6. And minus 1 plus 7, it's equal to 6 again, is going to be. So here, as I repeat before, the dimensions are here 2 by 3 matrix and 2 by 3 matrix. Again, the result is 2 by 3 matrix. It's going to be. Okay, it is same for subtraction. Maybe I can write the subtraction example here one more time. Let me change the colors here. This is A minus B now, which is equal to A5, 0, 4, 0, 4, 2, 3, minus 1, and minus 2, 2, 1, 5, 3, and 7. It should be. Then it's going to be equal to 5 minus 2, it should be equal to 3. Then 0 minus 2, it should be equal to minus 2. 4 minus 1, it is equal to 3. 2 minus 5, it's equal to minus 3. 3 minus 3 is equal to 0. Minus 1 minus 7, it's going to be equal to minus 8. And this is again 2 by 3 matrix. It should be. Okay, and one simple rule. We are going to remember simply the rules. Then we are going to finish the video. Properties of the matrix addition. It says closure property, which means when you add 2 by 2 matrix by 2 by 2, the result again it's going to be 2 by 2 matrix. Which means if A is equal to M times N matrix and B is equal to M times N matrix. So the text here. Okay. Then the result, it should be m times n matrix, and this is called closure property. Commutative property, you can switch the places of the letters here, which means the matrices also. If I say a plus b, then this might be equal to b plus a at the same time. And the associative property, associative means together you can add b, c firstly, then you can add to a, or you can add a, b, then you can add to c. And identity means the zero, like 2 by 2 matrix for 2 by 2 matrix. If I add, let's say 1, 2, 3, 4 by 0, 0 means here, this is, if this is A, this is the 0 matrix it becomes. And here, A plus 0 is going to be equal to 0. You remember from the definitions of the types of matrices also this one. So the result is going to be again 1 plus 0 is equal to 1, 2 plus 0 is equal to 2, 3 plus 0 is equal to 3, 4 plus 0 is equal to 4, which is equal to a plus 0, it should be equal to 0 again. I have written here by mistake 0, but it should be equal to a again. And additive inverse means all of them they are negative. Here minus 1, minus 2, minus 3, minus 4. When it becomes then a plus minus a, it will be equal to 0. We know that one from the addition properties.